Well, hello, Team 6C, and welcome back from your weekend. I hope everyone had an enjoyable and restful weekend. We're going to do another math lesson this morning. We're still in Module 6, as you can see, Lesson 5. It's page S27. We're going to review a little bit of histograms, which we talked about last week, Thursday. Today, we're going to look at a chart here that talked about head circumferences. And remember, head circumference is the measurement around the outside of the head. So we'll use Jimmy here as our example. It says in Lesson 4, we investigated the head circumference that the boys and girls basketball teams collected. Below is the frequency table of the head circumferences that they measured. So remember, we had sizes from extra small to double extra large. The circumference measurements, and remember, we read this 510 millimeters up to less than 530. So that would basically mean like 529. 530 would be considered on the next row. We then did our tally marks, and then we found the value of the tally marks and wrote the frequency. Underneath our chart, it says that Isabel, one of the basketball players, indicated that most of the hats were small, medium, or large. To decide if Isabel was correct, the players added a relative frequency column to the table. Relative frequency, we'll go ahead and circle that word there, is the value of the frequency in an interval divided by the total number of data values. All right, let's see if we can understand what that means. So we have our frequency table right here. This is exactly like what we see at the top. But now we've added a relative frequency, and it said the relative frequency is the value of the frequency, this is 2, divided by the total number. Well, today we're going to take our frequency table and we're going to always make sure we have a total. So once we add all these numbers up, we have a total of 40. 2 people needed the extra small, 2 out of 40. And so basically, this is 2/40. We took 2 and we divided it by 40. Do a little review here. And we remember that we can't do that unless we would add our decimal place and we'd add some zeros. We know that 40 does not go into 2. 40 does not go into 20. 40 will go into 200, however, 5 times evenly. So that's how we got to this decimal point. Okay. Well, today I'm going to actually allow you to use your calculators. So what I'd like for you to do is, if you notice, this one says 8 out of 40, so we wrote 8 out of 40, and we took our calculators and we said 8 divided by 40, and we got the answer 2/10. Okay, I'm going to ask you to go ahead and pause the video and go ahead and finish writing these out, 15 out of 40, and then go ahead and plug that in your calculator and divide it and get an answer. Okay, so go ahead and look and see how you did here on your problems. Remember, the relative frequency is the total number of people who needed specifically that size. So, for example, a large, 9 people needed the large, 9 out of 40. So in my calculator, we took 9 and we divided it by 40, and that's how I got my decimal answer. What I'd like for you to do to kind of save us some time on the next page is go ahead and we're going to add way over here on the side, we're going to change these to a percent. A percent. We talked about percent when we were back at school and how we can change a decimal to a percent. Some of you might remember the quick and easy way to change a decimal to a percent. Okay, so when we look at our decimal right here, we can look at it mathematically and say that this says 5 hundredths. So I'll put 5 hundredths. When I read it, 5 hundredths is the same as this. And we already know that percent always goes over 100, and I'm over 100, so this equals 5%. So let's go over here and let's put that this one equals 5%. Now I could do the same for this one. So I have the decimal, which is basically 2/10, or I could change it to where it equals 20 hundredths. Whatever I do on the top, I do to the bottom, which equals 20%. Now, the quick method, which we all love, is if you notice, all I'm doing is I'm taking my decimal and I'm moving my decimal 2 places to the right to get my percent answer. So 2 places to the right would give me 20. If I take this decimal here and move it 2 places to the right, it's going to be at 37.5%. If I move this one 2 places, it's going to be at 22.5%. If I move this one 2 places, I have to add a 0 over there, so that's going to be 10%. This is the same as up here for the extra small hat, so we'll change this to a 5%. And obviously, if I have looked at everybody's circumference of their heads, I have a total of 100%. Okay, so I went ahead and made a copy of the chart we just made and took it over to the next page with us so we don't have to flip back and forth. We notice the first question says, what is the total of the relative frequency column? So here's my relative frequency column. It gave us a total of 1, which we basically know is 100%. So we're going to go ahead and put it as 100%. The next question says, which interval has the greatest relative frequency? Okay, so here's our relative frequency. We want to find which one has the greatest. Well, obviously, we have here the medium is the greatest. It had 15, gave us this decimal, and here was my percent. So what was the greatest? I said the greatest here was the medium-sized hats. Kind of put the measurements. If you notice, I said the measurements are from 550 to 569. Hopefully some of you are catching on. The reason I had to put this is because medium has to be less than 570. It cannot be equal to, and so I just went ahead and put that. My value, when I looked over here, the value was 375 thousandths. Okay, let's move down to the next one. What percent? Now, good thing we filled in the percent over here because that'll save us a little bit of time. It says, what percent of the head circumferences is between 530 and 589? So 530 is right here, so I needed this one and this one. And I'm going to even do the largest. So I took these 3 decimals right here from medium, or small, medium, and large, and I went ahead and wrote them right here. Now, since you have your calculator, you can go ahead and add that up. And if we put that in our calculator, we found out that the answer is 8/10. So we're going to go ahead and just write this right here. And we've already know that once we want to change this to a percent, we're going to move our decimal 2 places, which gives us a total of 80%. Okay, so the information that we just looked at now was made into a histogram for us. It says the players decided to construct a histogram using the relative frequencies instead of the frequencies. They noticed that the relative frequencies in the table ranged from close to 0 to 4/10. They drew a number line and marked off the intervals on that line. Then they drew the vertical line and labeled it relative frequency. They added a scale to this line by starting at 0, and then they counted on the bottom here by 500 until they had reached 4/10. They completed the histogram by drawing the bars so the height of each bar matched the relative frequency for the interval. So let's look at exactly what we're talking about. So if I pull this back, we notice here our smallest decimal we've got here, we went from 500ths, and then we went all the way, we have up here to 375 thousandths. Put that up would be helpful, wouldn't it? And so that's how they looked at these decimals here to decide what to count with. So they have a pattern here, and they called it relative frequency, which was this chart here. Then we had our horizontal line, and we know that we're talking about head circumferences, so we labeled that here. Now, last week I kind of talked to you about these little 2 squiggly lines here. This gives us what we call like a broken graph, bar graph. It allows us to jump from 0 all the way to 510. And then if you look at your book, then we continue to count. We have a pattern. We counted by 20s, but obviously we don't want to start over here with 0 and start with 20, 40, 60, and jump all the way to 510. Our graph would not fit on the paper. So we're going to add this little squiggly line to give us the opportunity to jump to 510. And then all you will notice is we kind of drew the bars for the extra smalls. The relative frequency was 500, so they drew it up to 500ths. We looked at the next one for the small hats, and we had to go up to 2/10, so we drew it up here, and so forth. So we basically are making the bar graph, but we're using this information this time instead of the frequency information that we used last week. Okay, so we're going to turn over to page S29. I went ahead and made another copy here for us so we don't have to flip our book back and forth. But we're going to kind of look at what we talked about once again last week. It says describe the shape of the relative frequency histogram. So here's my histogram. Remember last week I had you take your pencil and we kind of drew and kind of tried to touch the bars here to see what it looks like. Symmetrical means we could fold it in half and it would match. It's pretty close to symmetrical. If I would fold it in half right here, these two bars are pretty close. This one's pretty close to this one, but I have this extra bar right here. And so it doesn't quite make it symmetrical. And because this side is the little bit longer side, we talked about going down the slide, how this would be, this is going to be our ladder side. So even though it's not obviously skewed to the right, we're going to go ahead and just say that it's slightly skewed to the right. Next question says, how does the shape of this histogram compare with the frequency histogram you drew in exercise 5 of lesson 4? All right, so I went ahead and turned my pages back for you, back to lesson 4, which we did last week. We already made this graph, and if you notice, this is the one where we took the frequencies. 2 people needed this size, 4 people, 6 people. These were actually the number of people, whereas today we used the relative frequency. And if you look at my graph, they are almost identical except for the labels. So let's go back, and on my paper we're going to write down our answer. All right, so as we are back here at problem B, and it says how does the shape of the histogram compare? Well, we just looked at both of them and the shape looks the same. The shape is the same, it's just the labels were different. So go ahead and write that. And then actually next question we actually have already answered as well. It says Isabel said that most of the hats that needed to be ordered were small, medium, and large. Was she right? Well, when we look here at our graph, this is the small, medium, and large, and that is the majority of the hats. That is correct. We solved this when we looked back here with our small, medium, and large, the percentages that were needed. So what I did is I put on here that she was right. The total percentage was 80. And we added that up with our calculator on the previous page. And then the question wants to know, well, what percent of the hats to be ordered is small, medium, or large? And we solved that here on our paper as well. And so all I did was copy that information and put it right there. So I'll give you an opportunity to go ahead and write that down on your paper. All right, so now we're going to look at a different table. The table we have down here says, here's the frequency table of the seating capacity of arenas for the NBA basketball teams. Pretty interesting since we can't watch them right now. We will notice that some of the arenas can seat from 17,000 up to less than 17,500. There were 2 arenas, a frequency of 2. We have number of seating all the way down till we get to less than 22,500. Tally marks have been made. Frequencies have been filled in. We need to solve the total first. So go ahead and if you would please put the word total and make us an extra box for us. And then we need to add up the total. All right, so if I add all of these up, and if you need to use your calculator to do so, you can, but we need to find the total. And after you add all of them up, you should have found that there should be 29 of them. And so if you notice, we actually have already answered the questions, what's the total here? So we'll put a 29. Then part B says to complete the relative frequency column and round it to the nearest thousandth. So let's do the first few together, and then I'm going to ask you to pause it and go ahead and finish. Once again, the relative frequency, we have to take the frequency number and we have to divide it by the total. So we're going to put right here 2 out of 29. We're going to take our calculator and we're going to do 2 divided by 29. And we found the answer. Now, if you notice, we're not going to put this whole big answer because it says we need to round it to the nearest thousandth. And we have learned that this is the tenths, hundredths, thousandths. So my 8 is in the thousandths place. So if I stop right here, there's what I my thousand spot, I need to look at what's past the 8. And this number is going to either tell me to go up or leave it alone. It's a 9, and so the 9 will tell me to raise the 8 to a 9. So my answer is going to be 0.069. 0.069. Let's do the next one. So now we have 1 out of 29, so we'll put 1 over 29. And we'll take our calculator and we'll do 1 divided by 29 equals. Once again, tenths, hundred, thousandths. I have a 4. Okay, what's after the 4? It's a 4. The 4 tells me to leave it alone. So my answer is going to be 0.034. Okay, so go ahead and see if you can fill in the rest of this chart, and then turn your video back on and see if you did it correctly. Okay, so here's my relative frequency column after being finished. It's kind of nice because if you noticed, I actually repeated a couple spots. The 2 out of 29 was also down here. The 1 was listed twice, and then I had a lot of 5 out of 29. I went ahead and added a 0 here in front of my decimal to make sure that I did not have a whole number as part of my decimal answer. Okay, when you are finished checking this or completing this or writing this down, go ahead and turn to the next page. All right, so we are going to actually construct a histogram. We're going to do this last page and then we will be finished. First of all, we're going to have to draw our horizontal and our vertical line. So I like to take something that might be handy, whether it's a book. I'm using Claire's pizza order form here, and I'm just going to lay it down like this. And I'm going to go ahead and make my 2 axes, like so. Okay. Then it says I'm going to need to label them. Well, we're going to label this down here, NBA, and it's arena capacity. Okay, and then over here on this side, we're going to call it relative frequency. So I'm going to turn my book and do relative frequency. Okay, obviously we're going to have here the 0. Okay, so we're going to go ahead and label our relative frequency side first. We're going to look at our numbers here, and we're going to go ahead and I'm going to have you just kind of write down what I'm going to use. That we're going to go ahead and do basically what the other chart did. I'm going to put here 500ths, and so then I'm going to come up here and do 10, 15, 20, and we'll go up here to 25. And there we have our decimals. Okay. Okay, now we are not, if you remember, the seating here was 17,000. I know it's pretty tiny, and there's no way I want to start here at 0 and try to get all the way to 17,000 on my little graph. So we're going to go ahead and put in our broken graph here, just kind of a up, down, up thing. And then I'm going to start here with my 17,000. I know it's kind of hard to see, so you might have to flip back over. We're going to do 17,000 to 17,500. So I'll go like this, and I will do 17,000 to 17,500. Okay, so I'll put a next line, and we're going to go to 18,000. And then we'll go to 18,500. We've got our pattern here, 19,000, 19,500, 20,000, 20,500. I'm only going to have enough room on my graph to go up to 21,000. Okay. All right, so I'm going to go back and look here at this tally mark. Here I have the 17,000. According to this, and I apologize it's so small, we had to go up to the 0.069. So to me, that's going to be somewhere in between here. So I'm going to make my bar, and I'm going to come up about right there and down. Now, if I look at the 17,000 to 18,000, 17,000 to 18,000 went up to about 0.034. 0.033 is going to be less than 5, so that's going to be smaller down here. 18,000 to 18,500. Let's see what we can find here. 0.207. Let's get 0.2. That's going to go way up there. 18,500 to 19,000. Let's see. 0.172. This is 0.15. 17 would be somewhere about right there. And the nice thing is, if you notice, we had 0.172 3 times. 1, 2, 3. All right, then 20,000 to 20,500 for me is, oh, it's the same as the first chart. And the very last one that I'm going to do and have room for is my 20,500 to 21,000 is the same. All right, so I just basically wanted to give you a little bit of experience to kind of see how a histogram is made. We're going to go ahead and just X the rest of these out, and then I will see you all tomorrow.